Welcome to our deep dive into implementing relationships in database design. This is a crucial step in translating your entity relationship diagram into a functional database schema. We'll be breaking down how each type of relationship defined in your ER model gets translated into actual database constraints and tables. Remember that in an ER diagram, entities like passenger, booking, and flight are connected by different relationship types. During the, quote, implement entities step, identifying relationships become foreign keys. All other relationships are implemented in the, quote, implement relationships step, either as foreign keys or as brand new tables. Let's start with many-one relationships, which is the most common type you'll encounter. A many-one relationship translates directly into a foreign key. Critically, this foreign key is placed in the table on the many side and references the primary key of the table on the one side. For example, booking referencing passenger. Here's how this looks in SQL, ensuring the column is not null. Passenger ID int not null. Foreign key, passenger ID, references passenger, passenger ID. Next, we tackle one-one relationships, where each record in one table corresponds to, at most, one record in another. Like the many-one type, a one-one relationship also becomes a foreign key. It can go in either table, but best practice suggests placing it in the table with fewer expected rows to minimize null values. The foreign key column must be unique and not null if the relationship is required on the opposite side. For a one-one constraint, the SQL will include unique and not null constraints. Passenger ID int unique not null. Foreign key passenger ID references passenger, passenger ID. Finally, the many-many relationships require a special approach because they cannot be solved with a simple foreign key. A many-many relationship requires the creation of a new intermediary or weak table. This table resolves the relationship between the two entities. This new weak table contains two foreign keys, each referencing one of the related tables. The composite of these two foreign keys together forms the primary key of the weak table, guaranteeing uniqueness for the combination. Here is the SQL structure for a many-many weak table, such as student course, including the composite primary key and foreign key constraints. Create table student course. Student ID int not null. Course ID int not null. Primary key. Student ID. Course ID. Foreign key. Student ID. References. Student. Student ID. Foreign key. Course ID. References course. Course ID. As you implement these relationships, consistent naming conventions are key for clarity and maintainability. Foreign key names are typically based on the referenced primary key, such as passenger ID. You can optionally include prefixes derived from the relationship name, like booking passenger ID, for greater context. Weak table names are usually formed by combining the names of the two related tables, such as student course. An optional qualifier, like student course enrollment, can be added for extra clarity about the table's purpose. We have covered all the fundamental relationship types and how to correctly implement them in your database design. By ensuring many-one and one-one relationships are foreign keys, and many-many relationships become new weak tables, you successfully bridge the gap between conceptual ER design and physical database reality. With the relationships fully implemented, your logical design is complete and ready for the next stage of development. Relationships implemented, design complete.
All right, so let's look into implementing relationships. And we have steps here, that is step 6A, step 6B, and step 6C. So the activities here that you're going to do is, when you're doing step 6A, you're implementing many-one relationship as foreign key on the many sides. If you take step 6B, you're actually implementing one-one relationship as a foreign key in the table with your rows. If you take step 6C, you implement many-many relationship as a new weak table. So now that we've gone through this activity, I want us to do this participation activity so that we gauge yourself how we are faring on. So here we have questions. Foreign keys always have the same name as the reference primary key. The foreign keys always have the same name as reference primary key. Okay, so unfortunately for this one I already did. So if you chose true, you have to know that foreign key names include the names of the reference primary key and the optional prefix. derived from the relationship name. So this is actually false because foreign key names include the names of the reference primary key and an optional prefix derived from the relationship name. Alright, so to the next question, many one and one relationships are always implemented before many relationships. So this is false because relationships can be implemented in any order. There is no need for which one precedes the other. Let's get to the third question. The primary key of a table implements a many relationships is composite. So many relationship becomes a new weak table. That's true. So the primary key of the new table is the composite of the foreign key, referring to related table. Now let's get to this another activity and test our understanding on this concept of implementing relationship. So here we have entities, attributes. These entities, attributes become tables and primary key. Alright, so we have the taxi, we have the taxi fleet. Okay, so let's get to this. So when you're looking at this schema, we have foreign key placement. So the foreign key is placed in the taxi table. Reason, each taxi belongs to one taxi fleet. So the taxi table needs a reference to the taxi fleet it belongs to. The name of the foreign key, the foreign key column will typically be named taxi fleet ID, matching the primary key of the taxi fleet table. So this will ensure consistency and clarity in the schema. So is the foreign key column required in this case? Yes, the foreign key is required. Reason, every taxi must belong to a taxi fleet and the relationship is mandatory. So the taxi fleet cannot be down. So for the first part, we implement the relationship as a foreign key. We're going to add taxi fleet ID. Okay, so we're going to add taxi fleet ID to the taxi table. So it's taxi fleet ID. So we're going to pick for the first question concerning foreign key implementation, so the first question asks us in which table is the foreign key placed. We're gonna say taxi because each taxi belongs to one taxi fleet. So the table must be referenced taxi fleet. So we're going to take taxi fleet, right? So that is correct. Then what is the name of the new foreign key? So this matches the primary key of the taxi fleet table and keeps naming consistent. So we are going to use the foreign key taxi fleet ID. Okay, good. So we're going to take taxi fleet ID. So is the foreign key required? Yes. Why? Why is the foreign key required in this case? Because every taxi must belong to a taxi fleet. So the foreign key cannot be null. Let's check the answer. So we actually failed. We failed. So the reason why we failed is because the foreign key goes in the taxi table. Okay. So the many side relationship. So the foreign key goes in the taxi table. So what was expected was taxi. Okay. So the foreign key refers to taxi fleet ID. So the primary key on one side. If a many relationship is optional on one side, the foreign key is not required. So taxi fleet is optional in the relationship. So the foreign key is not required. Let's try again. Of the campus and university. All right. So, in which table is the foreign key placed? We'll say campus because each campus is part of one university. So, the campus table must be referenced university. So, we'll say campus. This is where the foreign key is placed. And then, the second question: what is the name of the new foreign key? That will be university ID because this matches the primary key of the university table and ensures consistency. So, we'll say university ID. So, is the foreign key required in this case? So the answer should be, we could remember the other time we failed, so the answer should be no. Let's check. No, we almost there, then just fail again. The foreign key must be there. So in many one relationship, one side the foreign key is required, so it was required in the relationship, so the foreign key is required. So in which table the foreign key be placed? We'll go with state. What is the name of the few new, we call it city code, and is the foreign key required? Yes. All right. All right. Then we go to the next question. Okay. In the many relationship, what are the foreign keys in the table? So the foreign keys in the table in this case is both student ID and course ID. Good. So to the final question, in the many relationships, select the possible primary keys of the new type of the business rule. So the primary keys are this and this. So we have to repeat that. So they're saying the many relations as a new table. Select only possible primary keys of the new table for business rules. So you have person ID, publication name, person ID, and the composite of person ID, person, publication, and the third column on the new table. So let's check this. Mhm. So what is expected is a composite, and this is the explanation. So we needed the 3 and the 3. All right, so